Alright, so today we're doing limits at infinity, and there are some few things to note before we get on to questions. So as a limit, as x goes to infinity, there's a hack in, finding the limit of a horizontal asymptotes is look at the numerator and the denominator, and if the coefficients are the right exponent, you can just divide or rather, if the variable are at the right same exponent, you can divide the coefficients, and that will give you the number at which the graph will oscillate towards once it goes to infinity. And something different works for these. If the numerator's exponent is less than the denominator's exponent, your graph will ultimately oscillate towards zero, because if the denominator is being held at a higher power, then this will always be a greater number as it goes to infinity. It'll just get way larger than this exponentially. So bigger denominator means the number gets closer to zero. And we're also going to go over horizontal asymptotes. That's just basically when the graph as it goes to infinity or negative infinity, it reaches one number, but it never actually hits that number. And same thing with vertical asymptotes. As a y value goes to infinity, the graph reaches a x value, which could be 2 or could be anything. And another way of finding the limit as a graph goes to infinity is using derivatives. So if we find the derivative of the numerator and the denominator separately, we could also deduct that the graph will oscillate towards 2 over 3. So let's get towards the questions. Let's start with number 1. Explain in your own words the meaning of each of the following. Limit as x goes to negative x goes to infinity, fx equals 5. So what this is basically saying is as the x value goes to infinity, the y value it reaches 5. So well, we could just draw like a mock graph, which could be just something like this. Let's say this is 5 right here. Or it could come from the top as well. Doesn't matter. That's basically just a horizontal asymptote is all what we're showing here. And b, as limit as x goes to negative infinity, fx equals 3. So what this is showing is as x goes to the x value of negative infinity, which is to the left, our graph will ultimately try to reach the y value of 3. So that could look something like this. Let's say 3 is right there. It could be from the bottom, the top, as long as it's going towards the left and it is the function is going towards the y value of 3. Alright, so let's try number 3. For the function f whose graph is given, state the following. So a is limit as x goes to infinity, uh, fx. So this is the graph we're going to be basing all of our answers off of. So infinity is to the right, and we could kind of see that the graph is having a horizontal asymptote at -2. So ultimately our answer would be -2 here. And b is as limit as x goes to negative infinity, what's the function value? So this is, we can see that the graph also has a horizontal asymptote at 2 over here, the y value of 2, so that's our answer. For c, as limit x goes to 1, what is the function value? So at x equals 1, we could see that the graph is having like a vertical asymptote. So we could say the function value is x as x goes to 1 is infinity, which in this case, going back to continuity, this wouldn't be a continuous function, but the limit would be the same. The limit would exist, um, but it would be discontinuous because the limit from the left and the right side are the same, but the x equals 1 in itself isn't defined. So d is limit as x goes to 3. What is the function value? So 3 is right here. And we could also see 3 is having a vertical asymptote. So this would be the opposite, negative infinity, because it's from the right and the left side, they're both going down. and the equations of the asymptotes. So x and y. So the x values at which a graph is having an asymptote is so we know there's a vertical one at 1 and 3. So we would just write 1 and 3. And the y values at which there's a horizontal asymptote is when it goes to negative infinity and infinity, which is 2 and negative 2 as we deducted. All right, let's move on to these few questions right here, and we're gonna answer these using the kind of hack that I related to, and also by deriving the equations. So number 15, let's try the hack that I deducted. So let's take the highest x value numbers in this function, which would be 4x over 5. And if we just solve for that, x crosses out, and then we're left with 4 over 5. So as x goes to infinity, our y value would be 4 over 5. Now let's do number 16. We could see that the denominator actually has a higher power than the numerator because the numerator has a power of, it doesn't have an x value, and the denominator has a power of 1 for x. So for this, let's say we plug in infinity, where you plug in numbers infinitely large. The denominator would only get bigger, but the numerator would never get bigger. So if the denominator is just getting bigger and bigger, wouldn't that mean that the graph is oscillating towards the y value of 0 as it goes to infinity? So that would be our answer. So number 17 is this little equation right here. Now let's use the rule of derivatives. So let's just use a simple power rule. So if we find the derivative of or for the first derivative of the numerator, we get 6t, and then this would be plus 1. And on the bottom, we would get 3t squared minus 4. And let's find the second derivative because we want to get rid of the t's, or as much as possible. So second derivative would be 6 over 6t. Yeah, 6 over 6t. So what we could see here is that denominator power is actually greater than numerator. So like we talked about in number 16, the denominator would get infinitely large and the numerator wouldn't get as large. So we could deduct that the limit as x goes to negative infinity this time would be also 0. Because let's say this is going towards negative infinity. Like if the numbers get larger on the negative side, we still get a really big negative answer on the denominator, which just means that, it's becoming a smaller number except from the negative side of the graph. So it would also go towards 0. So let's try number 18. So limit as t goes to negative infinity, 6t squared. So let's take the highest powers here. We got 6t and negative 2t squared. Or 6t squared, negative 2t squared. So let's write it out right here. So if we solve for it, t2, and then we get negative 6 over 2, which deducts to negative 3. So as the limit of t goes to negative infinity, we could deduct that it goes to negative 3. Because even on the negative side, negative infinity, it goes to negative 3, and to infinity, it goes to negative 3. So that would be your answer for that. And for number 19, we can do the same thing, grab the highest power, r cubed over 3r cubed. Now if we get rid of the r, that would give us just 1 over 3, or negative r actually. So it'll give you negative 1 over 3. So as the r value goes to infinity, our limit is negative 1 over 3. And number 20 here, let's derive the function. So if we find the first derivative, we'll get 9x squared minus 8. And then on the bottom, we'll get 12x squared minus 10. or 12x squared minus 10, yeah, 10x. And if we derive it again, we'll get 18x on the top, and then on the bottom we'll get 24x minus 10. And now if we derive it one more time, we'll get 18 over 24, which that, if you simplify it, that would just give you 3 over 4. So 3 over 4 would be the number that this function would reach, the y value, as x goes to infinity. So what we did, we just derived both the numerator and denominator till we got a constant number, which that would be, the y value that the equation would go towards. And now number 21. So you could see for number 21, we're dealing with some radicals here, but let's rewrite it this way. So we'll grab the biggest powers, which is obviously the x. So if we rewrite it as negative x to the 1/2 power, and then on the bottom we get x 1/2, it kind of looks a little bit easier, to look at than the radicals. So same thing here, half x half. If we divide both those, we're left with a negative, which would just be -1, because 1 over here. So -1 would be the y value that as x goes to infinity, that would be the limit. So yeah, even with the radical, don't panic. It's you could use the same formulas and thoughts for that. So yeah. All right, so I want you guys to try number 4, and number 4 is just figure out these limits based on this graph right here. So I'll give you guys a few seconds to do that. All right, so let's see what we're looking at right here. This graph, just off the bat, we could see that there's a horizontal asymptote right here at the ends, a vertical asymptote right here, a vertical asymptote right here, and yeah, it's basically what we could deduct. So let's do number A, or letter A rather. Limit as x goes to infinity, g of x is, so as x goes to infinity, we will be oscillating on the y value of 2. And then for b, as limit as x goes to negative infinity, for this is a y value of -1. And then c, as limit x goes to 0, g of x reaches negative infinity, as we can see. And for both of these, limit as x goes to 2 from the left side and the right side. So the uh, cool thing about 2 is that it's still a vertical asymptote, but the limit does not exist because from the right and the left side, it is not the same. But like if you write them separately, they would exist. So limit as x goes to 2 from the left side, because it's a minus, that would be negative infinity. And then limit as x goes to 2 from the right side, because it's a plus, that would be infinity. So they still exist, but the limit as a whole does not. So the equations of the asymptotes, let's write out x equals and the y equals. So x equals would give us the vertical asymptotes, which we already deducted. That's x equals 0 and x equals 2. So 0 and, 2 and 0. And y equals, that would give us the horizontal asymptotes, which we deducted are at y equals -1, which is right here, and 2. So -1 and 2. That would just be, that's our final answer. All right, so I want you guys to try number 5, 6, and 7. So what you have to do is follow these criteria, and you want to sketch some graphs, sketch a graph of each of them that satisfies all the given conditions. So you can pause the video and take a second to do that. All right, so let's look at number 5. So number 5, the criteria is at the point of at x equals 2 is 4. So this is a point that must exist on the graph, and then -2 and 4 is also a point that must exist on the graph. And we're also given that the limit as x goes to negative infinity is 0, which is our first horizontal asymptote, and our other one is as x goes to infinity, it's 2. So first, let's draw our points out so that we don't forget. 1, 2, 3, 4. Then this would be our first point, and then that would be our second point. So from the left side, it should have an asymptote at 0 as it goes to infinity. So we can draw something like that. So that means it'll never touch the x-axis, but it'll get ever so close to it. And we can connect our two points as well. And as x goes to infinity, f of x equals 2. So we would just draw a horizontal asymptote going towards 2. 2 is right here. So that would that's a viable graph or acceptable graph for number 5. And let's try number 6. So f of 0 is equals 0. So 0, 0, the coordinate is our first point, and our first limit is at x, as x goes to -1, f of x it goes to infinity. So what this is implying is that we have a vertical asymptote at -1. I mean, not -1, 1 from the left side. And then this limit is telling us that uh, when x goes to 1 from the right side, we have a vertical asymptote at negative infinity. And so we could do something like x equals infinity or something. Or rather, x equals 1, x equals 1 there. So we'll have vertical asymptote at x equals 1. And then for this is telling us as the limit as x goes to negative infinity is -2. So we have a horizontal asymptote at -2. And then at limit as x goes to infinity is -2. So we have another horizontal asymptote at -2. So let's first plot our point. So 0, 0, that's our point that needs to be there. And so 1 will be right here. So as x goes to 1 from the left side, which is right here, we need to be reaching infinity. So that would look something like that. And then as the graph reaches 1 from the right side, we need to be reaching negative infinity, which we could draw it as something like that. So that is our vertical asymptote. We have just checked off these 3 criteria. And now we need to be drawing the horizontal asymptotes. So let's try doing that. So as x goes to negative infinity, we are getting the horizontal asymptote at -2. So we could just draw here, -2 is going to be right here. We just draw something like that. And then as x goes to infinity, we have another horizontal asymptote at -2. So for this, or rather, actually, we could cross out that little bit. So the graph should look something like that. This little bit, forget about this bit. So this is pretty much how the graph should look, and what would be an acceptable answer. So let's move on to number 7. The limit as x goes to 0, f of x goes to infinity. So what this is telling us is that there's a vertical asymptote at x equals 0, and then the limit as x goes to 3 from the right side, f of x goes to negative infinity. So this is another vertical asymptote at 3. And then from the right side, the limit f of x goes to infinity. So this is another vertical asymptote, the same vertical asymptote. And this one is a horizontal asymptote. So this is as the limit x goes to negative infinity, f of x equals 1. So it's a horizontal asymptote at 1. and then this is to infinity. This is a horizontal asymptote at -1. So first let's draw out our asymptotes. So we know as the limit x goes to 0, there's an asymptote at infinity. So let's draw that. So at 0, that's the asymptote, first vertical asymptote, we're done with that. And then the limit as x goes to 3 from the right side. So let's draw 3. 1, 2, 3. So from the left side, the limit as x goes to 3 is negative infinity. So that'll be something like that. And then as from the right side of 3, the limit is infinity. So that will look something like that. And now we just checked off these two criteria. Now we gotta do the horizontal asymptotes. So as the limit as x goes to negative infinity, we reach a y value of 1. So let's say 1 is right here. So this would just be your horizontal asymptote. So we're done with that. And then as the limit as x goes to infinity, y goes to -1. So let's say -1 is right here. So from the right side, this graph should be coming down here, and then it's going to have an asymptote at -1. So this is what your number 7 graph should look like. It's followed all these criteria, or rather all these 5 criteria. No, that's basically it for these 3 questions. Alright, so now we're going to be doing all these questions, so I want you guys to try all these out. So you can pause the video now and try it out. Alright, so let's take a look at number 23. So we could use the same rules we used before, either deriving or taking the greatest coefficient and power. So for this, we could take the greatest power. So the greatest power would be square root 3x squared, and the bottom it would be 4x. So in order to get that x squared out, we have to square root that. So we could actually change this into square root of 3 times x. We have square root x and then over 4x. So now all we need to do is simplify. So cross out the x, and we're left with square root of 3 over 4. That would be your answer. That's the limit as x goes to infinity. So number 24, as t goes to infinity, we have this little equation right here. So we could do the same thing here. On the top, we'll have t, and then on the bottom, we'll have square root of t squared. So what we could do is separate the square root from t. Have t on the top, square root 2 times t. So now we can just cross it out, and then we're left with 1 over radical 2. That is our limit. And now for 25, we'll just do the same thing, 4x to 6 power over x cubed. We could actually square root everything in there, so we'll end up with 2x cubed over x cubed. So in that case, our limit would be 2, just 2. And oh, this is the same thing, except x is traveling to negative x now, negative infinity now. So for this, we could like kind of really do the same thing, except let's try deriving it now. So radical 4x to 6 power over x cubed. Let's 2x3 over x cubed, same thing as before, except now if you derive it, we get 6x squared over 3x squared. Derive it again, we get 12x over 6x, and then was it fourth derivative or third? We get 12 over 6, which is also 2. So that would be your limit as x goes to negative infinity. And now number 27. So number 27 is a bit different from the other questions we've done. Here, the power on the top is actually more than the power on the bottom. So let's isolate the powers real quick. We get 2x to the fifth power over x to the fourth power. Now if we simplify this, we get 2x. So given like now that we have 2x, if we plug in and numbers that get infinitely larger on the negative side, what do we get? Because 2 times, let's just say hypothetically negative infinity. We get a positive times a negative is a negative. So we would get a negative number that is getting infinitely larger, which is also represented by negative infinity. So that would be your limit, negative infinity right there. Number 28. We also have a numerator that's bigger here. So, oh, not g, q, cubed over 4q squared. So if we simplify this, we get q over 4, which is also 1 over 4, 1 over 4 times q. And now as this goes to infinity, um, since the numerator is bigger than the denominator, as the limit as q goes to infinity, means that this number is going to get infinitely larger. And it's going to just be multiplied by 1 over 4. Now if q gets infinitely larger, the 1 over 4 doesn't do anything. It's not important anymore. It's not going to make the number any smaller if it's going to infinity. So your answer, or your limit rather, as q goes to infinity would be infinity. Or not even that. That's a terrible drawing. Infinity, that's perfect. Now number 29. So this is a bit different than the other ones. This is not a fraction, but we could do the same thing here. Take out 25t squared, and then let's also take out minus 5t. So let's actually simplify 25t squared, and we get 5t. And we will, it's minus 5t. So the limit as t goes to infinity, let's say 5t and 5t get infinitely greater. It's always gonna equal 0 because while they get infinitely greater, they're the same number. They're same number being subtracted, it's gonna be 0. So your limit as t goes to infinity is 0. And that's all the questions there. All right. I hope you guys understood limits at infinity. So, the basic rules of, using this power rule or rather power hack in order to find the limit as horizontal asymptote limit, and also using deriving the function as well works. We went over vertical and horizontal asymptotes and knowing where to identify them. And also one really important thing that might catch you off guard is let's say there's a vertical asymptote as a number from two different sides, but they're going towards like a different scale of infinity, negative infinity and positive infinity. That's still a vertical asymptote. However, the limit does not exist there. The limit, since they're both different. So that is one important thing to note. But yeah, otherwise, yeah, that's basically it.